At an internet data storage provider, how do the relative proportions of users with free accounts versus users with premium paid accounts change with time? If we could predict the proportion of users with premium paid accounts, we would be able to determine whether the price we charged these users could cover the costs of the entire business operation combined. In a system with more than one moving part, the dynamics of each part might depend on the states of all of the parts taken together. An internet data storage company might seek to expand its customer base by offering free access to so-called introductory user accounts with limited storage capacity. Customers enjoying the free service can choose to upgrade to paid accounts affording premium storage capacity. Paying customers pleased with premium service might spread the word and recruit their friends to try the introductory free accounts. Users of free accounts feed into the premium user base, and premium users contribute to the free user base. The dynamic changes in one subscriber base going from month to month depend in part on the size of the other subscriber base. How can we analyze such a complicated system? When the customers act independently with, in a sense, short-term memory, so-called eigenvector-eigenvalue analysis can reframe the description of the dynamics of the system into pieces that look like one-dimensional dynamics. To understand this method, we need to become familiar with ideas about vector spaces and linear operators. Taken together, the sections reviewing vectors, linear operators, and eigenvector-eigenvalue analysis provide a basic introduction to practical linear algebra. This slide deck is split into 4 units. In this video, we will state the motivating case study. In the next video, we will introduce vectors, vector spaces, and the idea of a basis set. In the third video, we describe linear operators and their matrix representations. In the fourth video, we will use the perspective established in the second and third videos to solve for the dynamics of the composition of the Internet Data Storage Company's customer base. You are managing an internet data storage company that provides users access to their data online. It's as though they virtually plug into their memory sticks by logging onto your website. You have XP customers paying for premium accounts, and you have XF freeloaders using an introductory account with limited data storage capacity. You need to know how the composition of your user base will change with time so that your accounting staff can determine whether the revenues from the paying customers will be able to sustain the expenses incurred by providing both premium and free services. To predict how the customer base changes in time, we need to enumerate processes that can contribute to the dynamics of your customer population. A paying customer can recruit a friend to try out your service. For simplicity, say that in any given month, a fraction rho of the paying customer population persuades a new customer to sign up for free service. For example, if the fraction rho is 3/8, then 3 out of 8 of the paying customers initially present at the beginning of the month succeed in each persuading one friend to join the free customer base by the beginning of the following month. The hope is that customers who try the free service will like it enough to sign up for premium access. Let's say that a fraction upsilon of the free customer base upgrades each month. For example, if upsilon is 2/9, then 2 out of 9 non-paying customers present at the beginning of a given month will get excited about your service and join the paying customer base by the beginning of the following month. Unfortunately, some paying customers might decide they no longer need premium service. Let's say a fraction delta of the paying customer base downgrades from paid to free accounts. If, for example, delta is 1/4, then 2 out of 8 of the customers paying at the beginning of a given month will have left the paid subscriber roles by the beginning of the following month. Even non-paying users might choose to cancel their accounts. Let's say that a fraction alpha of the non-paying customer base cancels its accounts each month. If, for example, alpha is 2/9, then 2 out of 9 customers signed up for free accounts at the beginning of a month will have completely closed their accounts by the beginning of the following month. The table of events or so-called reactions can be written as dynamics in discrete steps in time. The non-paying and paying populations, XF and XP at time t plus delta t, can differ from the values of XF and XP at time t, owing in part to recruitment, owing in part to upgrades, owing in part to downgrades, and owing in part to attrition, meaning the cancellation of free accounts. The time step delta t is a month because we are tracking changes in the subscriber base from month to month. We want to express the dynamics of these populations of customers in a simple way. Before saying more about this motivating case study, we will use the next 2 videos to set the stage by introducing ideas about vectors, vector spaces, basis sets, and linear operators. This background will provide comfort with the eigenvector-eigenvalue analysis we will eventually use to solve our motivating example.